Alright, here we go. 10.1 practice video. Let's put in this work. So find the surface area of each figure. Round to the nearest tenth if necessary. So remember, surface area is if you were building this shape out of like wood or metal or something. So you think about every single surface, which is basically just made up of, triangles, rectangles, circles, trapezoids. So as long as you know the individual formulas for the area of each shape, you can just add them all together. So let's get after this first one here. I'm going to focus on the first thing is the two bases. This is a prism, and it's got two bases that are parallel to each other, and they're the same exact size. And it's basically this triangle right here, the ceiling, and the floor. So I kind of know that I have two triangles. So for two triangles, I got to know that the formula for a triangle is 1/2 base times height. So I have 2 1/2, and now I got to bust out the base and the height. Well, looking at my triangles over here, kind of get rid of this to make it a little easier to see, the base and height have to be perpendicular to each other. They got to meet at 90 degrees. So my base for the triangle I'm going to use is 9. And the height for the triangle is right here, that dotted line, which is 6.4. So right there is going to give me my top and my bottom, or the ceiling and the floor. So let's just bust this out real quick. Turn this little guy on. So, the 2 times the 1/2, I really don't need to punch that in because that's just 1. So I'm just going to do 9 times 6.4 equals... So right now we're at 57.6 for the top and the bottom. All right, so those guys are squared away. Now let's go after the walls. I'm going to do this front wall first. This front wall right here, the numbers that go with him are 9 by 10. So that's going to be 90. So this is kind of my front. If I now kind of focus my efforts over here on the side, so let's look at this side wall over here, kind of this back right. Well, that wall is 9 by 10, so that's going to be another 90. So this will be the right side. And then over here on the left side, I have 7, and they don't really give me the height right there, but I can kind of use it because the entire shape is 10. If this thickness or that height is 10, that means that this thickness is 10. So this rectangle is going to be 7 by 10, which is 70. All right, so I do my grand total here, add these up. I'll just do this by hand. 0.6, bring the 7 down. It's 1423. Looks like 307.6. So the correct answer for number 1 is A. All right, number 2. This one is basically a box, or the fancy name is a rectangular prism. They both mean the same thing. Any surface area problem I just add up all the sides individually. There are some books, and probably maybe even in the video notes, there is a formula for a rectangular prism, which looks something like this. It's 2 times the base area plus the lateral area times the perimeter. So, or actually the perimeter times the height. And this represents the lateral area or the walls. And this part represents, the floor and the ceiling, I guess, if you're kind of thinking of it as a box. I don't really use that formula. It's just a lot more things to remember. There's a lot of letters in here that you got to kind of keep track of. So again, I look at this shape and I'm like, hey, it's all rectangles. Let's just add up the rectangles. Now the nice thing about a box, so let me kind of get this out of here. The nice thing about the box is that they come in pairs. So if you look at this box, and I'm going to kind of color code this first, there's kind of like, and this one's kind of hard to say top, bottom, and right, left, but you have this little bottom piece right here that should match that little top piece up there. And then you have this side, this long, thin one over here, and then this long, thin one over here. Those two should match up. And then kind of getting rid of this so we can see easier. Then you also have this big, oh, don't even know how I did that. You also have this big front piece. And then right back here, you have the back piece. All right, so you kind of have two sets or two pairs of everybody. So that's kind of how I'm going to do this problem. So let's go. So my first rectangle, let's just do this little one off to the side. This one over here is 3 by 8. All right, so I have a 3 times 8. But then remember, there's another one over here on this side. There's another 3 by 8. So I have 2 of those 3 by 8s. For a grand total, that's 2 times 24. That's going to be 48 square centimeters. And now I'm going to come back here and I'm going to do a different one. Let's do this big piece. So these are 4 by 8. And I have 2 of those. So 2 4 by 8s, which is 64. And then lastly, I have the little slivers on the top and the bottom. And these pieces are 4 by 3. So I have 2 of those, 2 4 by 3s. And that ends up being 24. Now I add these guys up for a grand total. And 8 and 8, 16, carry the 1, that's 11, 12, 13. So we're looking at 136. Getting a little bit nervous there. Correct answer is D. Now, if you were going the other route, maybe I'll just show this one time. I'm not going to show it a whole bunch of times because it's time consuming showing both methods on every single problem. But if you really wanted to kind of do the 2 base area times pH, the first thing you'd have to do is realize what's your base area. I like to kind of put the bottom as the base area, so let's just call this as the bottom or the base. And so you're going to have 2 times the base area plus the perimeter of the base times the height of the prism. So looking through here, I'm going to have 2 of the base areas, and the base is 4 by 3. Plus, and now if I want to find the perimeter of the base, well, the perimeter of the base is all the way around. So you have 4, 3, 4, 3. So 4, 3, 4, 3, that's going to be 14 is the perimeter. And then the height is right there. So if I crank out this way, I'm going to have 2 times 12, which is 24, plus 14 times 8, 80 and 32, which is $112, which again comes out to be 136. So pick whichever method you like. I just have always done all the pieces separately. I kind of like that method. All right, number 3. Looks like we have a pentagonal or a pentagon prism. You know, my top and my bottom are pentagons, and then I have a bunch of rectangles there for walls. The nice thing about these shapes, and we're pretty much always going to do regular ones, is that since all the sides, this is a regular polygon, since all the sides are the same, all those walls are going to be equal. So this makes these very easy to deal with. So let's kind of set it up this way. Our ultimate goal is we're going to have 2 pentagons, all right, and then we're going to add to that 5 rectangles. These are the walls. So we need to know the formulas for both of those. So recall from chapter 9, the area for a polygon is 1/2 apothem times perimeter, and then the area of a rectangle, pretty easy. That's going to be 5 length times width, or some people like base times height. I'm kind of old school, length by width. So let's crack these out. So doing my pentagon, I have 2 times 1/2 times, well, the apothem, remember this little apothem piece right here, the apothem is that right there, which is 6.9. And then the perimeter of this dude is all the way around. So I kind of have to figure out how far is it all the way around that thing. And since every single side is 10, you know, they tell me right up here, they tell me that that's 10. So I have 5 of those. So the perimeter is going to be 50 all the way around. So that knocks out the top and the bottom. Now let's bust out the walls. And every wall is pretty straightforward here. Every wall is 10, 10, 10, 10, 10. But then it, whoa, sorry, I didn't mean to do that. But then it's got a height of 12. So each rectangle is a 10 by 12. So I have 5 of these 10 by 12 walls. So cranking all this out here, maybe I'll bust out the little calculator for this joker. So let's do, maybe I'll punch it all in. So 2 times 0.5, I know that's going to be 1, so that was kind of unnecessary, times 6.9 times 50. And then I'm going to add to that the 5 times 10 times 12. Probably should be using parentheses, but I know the order of operations on the calculator, so I'm pretty confident this is going to be good, except for I put 5 times 10 times 10. So I got to change that to 12. Boom, 945. Now I made this homework multiple choice just so that if you didn't get the right answer, you would see, so you could go back and try to fix it. But it looks like we did, so the correct answer here is D. All right, number 4. Number 4 is a trapezoid prism. You know, and the name's not huge. I mean, it's helpful to know that, but to calculate it, you really don't need the name of it. Just look at what shapes it makes up. So I basically have 2 trapezoids that match each other. You know, I have this front one right here, and then I have the back one right there. They're going to be the same. So I have 2 trapezoids. Whoa. Sorry about that. So I have 2 trapezoids, and remember, the trapezoid is base 1 plus base 2 chopped in half, the average of the bases, times the height. And then for the walls, I'm going to have a bunch of rectangles. So let's kind of go back and let's look at my walls. So I'm just kind of thinking like my main plan here. All my walls are going to be, I have a top, I have a right, I have the bottom, and then I have the left. And those, some of them look different sizes, so we'll kind of worry about that. But we know that we have 4 rectangles, and be careful that they're different. So we'll kind of go through and do those individually. Well, let's knock out this this trapezoid first. So looking at the trapezoid, I'm going to have 2, and the base of the trapezoid, well, the bigger base, the top is 7, and then the smaller base of the trapezoid is the 4, and then we're going to chop that in half, and then we're going to multiply it by the height, and the height is always denoted by that little 90-degree angle. So the height is 2.6. So that knocks out the trapezoid part. Now let's go back in here and let's deal with all of these different rectangles. So I noticed that I have a big rectangle on the top. So I have this big one up here that's 7 by 6. So I have a 7 by 6 rectangle. Then let's jump down to the bottom. The bottom rectangle is a little bit smaller. The bottom is only 4 by 6. All right, so the bottom rectangle is 4 by 6. And now with these trapezoids, since this is an isosceles trapezoid, it looks like the 2 side walls are going to be the same. So I have a 3 by a 6, because remember it matches this one. So I have a 3 by 6, and also over here I have a 3 by 6. So I have 2 of those 3 by 6s. So if you think about this thing, and something I kind of like to do at the very end is I always want to make sure that I have all the pieces accounted for. If I was going to build this thing out of wood, this thing has 6 faces. Top, bottom, right, left, front, back. So I got to make sure I have 6 pieces. And I think I do. I have 2, 3, 4, 5, 6. So all the sides are taken care of. Now we got to go in and we got to kind of crunch these numbers here. So crunching all the numbers, I have 2, that's going to be 11 cut in half, which is 5.5 times 2.6 plus, this is 42 plus 24 plus 2 18s is another 36. So let's just pull out the old calculator and smash all this in here. So 255s, that's 11 times 2.6. Add that to 42. Add that to 24. Add that to 36. Bam. 130.6. Awesome. Correct answer is C. All right, number 5. Looks like we got a cylinder. So a cylinder, if you open it up and if you actually looked at the net, the cylinder is basically just a rectangle with 2 circles hooked to it. All right. Now, one thing that if you were to make this out of a piece of metal or a piece of paper, one thing that you need to understand is that the circumference of the circle right here should match the exact length of this rectangle. All right. So whatever the circumference of the circle is, it should be the length of the rectangle. So, you know, this length here is actually C, and then we have the height. And then we got to figure out the area of these circles. So remember, each circle is pi r squared, and we have a top and a bottom. So we have 2 circles plus a rectangle is basically what we're doing. But then remember, the rectangle is it's not as easy as just length times height, because it's actually circumference times height. So if you use the formula, surface area is 2 circles plus the circumference times the height, or 2 circles plus circumference is just 2 pi r times the height. So all I kind of did here was just replace C with the formula that goes with it. So for these, you can kind of just plug and chug. Once you understand the formula and you have it at your disposal, you can just kind of plug and chug with that sucker. The nice thing about on the SAT or ACT is they give you this formula. So let's just get after it. So the surface area is going to be 2 pi. The radius is 6 squared plus 2 pi r. And then h is the height, which is 12. And this looks like a job maybe for the calculator. Let me kind of simplify it. You can go to the calculator right now, but I'm going to do 6 squared is 36 times 2. That's 72 pi. And then 2 and 6 is 12 times another 12 is $1.44 pi. So if I put all this together, added up all those pi's, that would be what, 216 pi? So if they wanted an exact answer, I would say it's 216 pi, but we can get an approximation for that. It's roughly 216 times 3. But let's get the calculator. So turn it back on. 216 times second pi. It's like 678.58, which would round to 678.6. All right, number 6 looks like we have another box, another rectangular prism here. So I'm going to just kind of bust it out, doing like top, bottom, left, right, front, back. So let's kind of start right here, and let's just do, this top box is 8 by 8, and then there's another bottom to match it. So I'm going to have 2 of these 8 by 8 rectangles, or squares, I guess. They're not rectangles. And then let's do the right and the left walls. So this was the top and the bottom. Now we're going to do the right and the left. The right is 8 by 12. And he's going to have a matcher over here. He'll have another 8 by 12. So we have two 8 by 12s. So that's, we're going to call that the right and the left. And then we're going to have the front and the back. This will be 8 by 12. Remember, it matches that one back there. So we have an 8 by 12 here, and we have an 8 by 12 there. So we have two more 8 by 12s, and we'll call that the front and the back. And let's just go ahead and let's crank out all these numbers. Might be able to do this one in my head. So right here we're looking at 264s. That's $1.28. Then we have 296s. That's what, 192. And then we have, two more 96s. So another 192. So 8 and 2, 10, that's 12. Carry the 1, 13, 12, 21. Carry the 2, 5, 12. Correct answer is A. All right, number 7, triangular prism. And we have two matching triangles. So the cool part of this triangle, there's two ways to find there's a bunch of ways to find the area of that triangle. The problem is, so I know that the area of a triangle is 1/2 base times height, right? And I know I have two of them because there's also a top triangle. And they both match, all right? They're both identical triangles. The issue is, you can't use 5. A lot of kids want to use 5 as the base because it's on the bottom. And that would totally be fine. However, they don't give me the height coming down there to the base. We don't know what it is. So I can't use 5 as my base. Now, the cool thing about a right triangle, all right, when you're dealing with a right triangle, the base and the height are actually two of the sides here. So I'm going to use one of these as my base, and the other one is my height. And kind of picture this triangle standing this way. All right, just kind of rotate it in your mind. So I'm going to use like maybe this 3 as the base and this 4 as the height here. So for my triangle, let's go back to the original equation. I know I have two of them. So I'm going to have 2, 1/2. We're going to use 3 as the base and 4 as the height. All right, so that right there is going to knock out the top and the bottom. Well, now we got to deal with some walls. Now we got to deal with some rectangles. So this back rectangle right here, that's 4 by 2. This big front rectangle is 5 by 2. And then we got this little side dude over here who's 3 by 2. And I think we got everybody on lockdown. All right, we have five faces on this prism. 2, 3, 4, 5. Now we just got to add them all up. See if we can avoid the calculator. 2 halves is 1. 3 times 4 is 12. 2 times 4 is 8. 5 times 2 is 10. 3 times 2 is 6. And I got 20 plus 16. Grand total 36. Correct answer C. All right, let me get this little thing out of the way so you can see what number it is. Number 8's another cylinder, so we're just going to go straight forward and use the formula. So surface area for a cylinder was 2 pi r squared. That knocks out the top and the bottom. And then the walls all the way around is just one big rectangle, which is the circumference times the height. So here we go. 2 pi radius squared. Remember, that's the radius. This is going to be my height. So plus 2 pi radius height. Let's bust that out. 2 squared is 4. 4 times 2 is 8. So I got 8 pi's in the front. And I got 3, 2 is 6. 12 pi's for a grand total of 20 pi. I like to do it like that first before I actually go to the calculator. Now I can punch in what is 20 times pi. So 20 pi, boom, 62.83. And I might make another little video for you guys to show you how to use this this graphing calculator. As long as you, well, actually, you don't even need a touch screen. You could use your mouse. But basically, you download this. It's called Wabbit EMU, and it's an emulator that runs different ROMs. And then you can just Google like TI-84 ROM. But I might make a video showing you how to do that. That way, if you don't have a calculator at home, you could use this graphing calculator on your Chromebook. Number 9, looks like we have another box. And I'm going to be honest, I don't really like how this box is drawn. Just the angle, like I don't like that this line and this line almost look like the same line. So it's kind of weird. So you could always, I'm going to just show you something that I do sometimes. You can always like redraw this thing if you want. So I'm going to kind of redraw it the way that I like it to be set up. So I'm going to just kind of do like this. Kind of draw a parallelogram. I come right up above. I bust out another parallelogram. Hook them together. Now you just got to make sure to label it properly. So I'm going to make this be my bottom. Whoa. Sorry about that. I'm going to make this be my bottom. This 9 by 11. Okay. I'm going to put that on the bottom. So 9 by 11. And then it's going to have a height or a thickness of 5. That kind of connects up to the other 9 by 11. So basically what I just drew over here to the right is the exact same box, but to me it just seems a little bit easier to deal with. If you can visualize the one on the left, cool. But let's bust this out. So I have a 9 by 11 and I have 2 of them, top and the bottom. So I have 2 9 by 11s. That's my top bottom. Then my right and lefts, I have a 5 by 11. And I have 2 of those. Another one over here. So I have plus 2 5 by 11s. And then we haven't talked about the front, which is a 9 by 5. And then the back, which is a 9 by 5. So we have 2 of those jokers. And let's go through and let's bust that out. So this was the right and the left. This was the front and the back. All right, 2 9 by 11s. Well, that's 99 doubled. So that's 198. Over here we have 10 times 11. So that's 110. And then we have 45 times 2 is another 90. And 110 and 90 is 200. Added to 198. Grand total 398. Correct answer B. Number 10, we got a, looks like a hexagon box. The nice thing about all the gons, they have the same formula. So since I have a top and a bottom, I'm going to have 2 of these hexagons plus, and since there's 6 sides there, there's going to be 6 walls or 6 rectangles to deal with. So my formula for a hexagon is 1/2 apothem times perimeter plus 6 old school length times width. All right, well, let's get after it. Let's pop some numbers in here. So I have 2 1/2. The apothem is chilling right there, 5.2. The perimeter of this thing. So remember, the perimeter is all the way around, and since every side is 6, I have 6 of those all the way around. So I'm going to have 6 times 6. So I'm going to have a perimeter of 36 all the way around. Now I'm going to get into the walls. So every single wall is right here. And all of those are 6 by a height of 4. So every one of those walls are 24. So I'm going to have 6 of those 6 by 4 walls. And let's go through here and see if we need a calculator or not. Maybe not. So I have 1, 36 times 5.2, gosh. So that's 150, 130, and another 0.2. It's 130 and 7.2. I think that's 137.2. I don't know, I might be biting off more than I can chew. And then I got 36 times 4, that's a double-double. So 36, 72, that's 144. Slap those dudes together, looks like 281. Oh man, I think I must have screwed this up somewhere. Yeah, I must have screwed up back here. Bit off a little more than I could chew, I guess. I think I made a mistake here on this front piece. So let's go. I guess I'll just cheat and use a calculator. I shouldn't. I'm getting soft during this quarantine. My math isn't quite as sharp. 5.2 times 36. And then we're going to add to that the 6 times 6 times 4. 331.2. Doggone it. Should have been able to do that in my head. Makes me mad. Same strategy on number 11. I'll go a little bit quicker here. So we have 2 1/2 AP plus 5 walls because it's a pentagon. So we have 2 1/2 apothegm 5.5. Perimeter is 8 times 5, which is 40, plus 5 walls, and every wall has a length of 8 and a height of 8. So it's actually square walls. All right, see if we can do this one without touching that calculator. So that's 1. That is 200 plus another 20. So we got 220 here. Over here we have 40 times 8 is 320. 220 and 320 is 540. That's a little better. B. All right, finishing with the trapezoid. We did one of these earlier, so I'll go kind of quick here. So we have 2 trapezoids, and the formula for a trapezoid is base 1 plus base 2 chopped in half, okay, times the height, which, remember, the height is chilling right there. So that 2.6, it's going to be out here. So that knocks out the 2 trapezoids. Now we got to bust out our walls. So our walls, well, our ceiling is 6 by 4. So we have a 6 by 4 ceiling. The floor is 3 by 4. And then our sides, this thing's getting a little bit cluttered, so let me just kind of wipe that out. Our 2 side walls are 4 by 3. 4 by 3. So those are 12. And let's see if we can bust at least some of this out without a calculator. So that's 9 over 2. So I have 2 4.5 times 2.6 added to 24 added to 12 added to 12. So this is all just 24 and 24 should be 48. So I'm going to have this plus 48, which is 9 times 2.6, which is 18, and 5.4 should be 23.4 plus 48. Again, if you want, just use a calculator. I'm just trying to challenge myself a little bit, which comes out to be 71 point. Why am I getting 71.4? Let's go back and see what I did wrong. 2 4.5 is 9. That's 18. 5.4. 23.4. Well, pretty sure my math is tight. Let's just see. Man, I need to get back in the classroom. Staying at home, I'm slipping. So maybe something in my formula is wrong. We have a 6 and we have a 3. Six by 4, a 3 by 4. Oh, I see what I did wrong. You probably spotted it before I did. When I did the very last one, I had 2 of these 4 by 3s. I didn't do 2 of them. So that adds another 12 to our total. Now we're cooking. So it wasn't my math, it was my setup. Correct answer is C. All right, man, we are done. Hopefully this helped you out. See you.